Hi, this is my second video for Paul's Pico W lesson number 26. I realised straight away that he wanted us to use Lissajous curves, partly from the title of lesson number 27, which was a bit of a giveaway, but I wanted to see if I could do it without using Lissajous curves, which is what I demonstrated for my last video. It wasn't perfect, and I've had to fudge the edges of the curve because I was using a sine wave and then turning it round to, when I reached the edge of where I wanted to be, I was then going backwards on the sine wave, but it meant that there was a point on it, so I had to get rid of the point. Anyway, just to see what I did in the last thing, I will just show you. I mean, this is I worked out the points so I wouldn't have to put sine in the loop. I thought that would make it quicker, and I'll just run it, and it isn't great, but it was just what I came up with, trying to see if I could do it by myself without Lissajous. Right, there you have it. It's a bit pointy, as you can see, but that isn't what I want to do, so off we go. This is now the real program. So I'm using Lissajous theorem, equation, whatever, and the equation is x equals capital A times sine of a times t plus delta, and y equals capital B of sine b times t, and t is the number of degrees that you're at, and capital A is what you use to control the curve width, and it will end up twice what A is, and capital B is the height, and equally that will be twice the height, and then you have little a and little b. Now little b is the number of peaks on the curve, so a Pringle only has 2 peaks, and if you have a is less than b, then it rotates horizontally. If you have b is less than a, then it rotates vertically, and then the only other thing that I've done is the speed. The speed can be from 1 when it moves very slowly, and then you can increase it right up, but it does have to be a factor of 360, because otherwise you won't get a perfect rotation of the curve. Now Keith did some timings on his circle video for how long it took to do things, and he found that if you worked out the x and y point for drawing a circle using the radius, then it took longer doing it with sines and cosines than it did when you were, oh no, it wouldn't have been sines and cosines, it was just sines. So it had quite an impact on it that you were actually, every point, every pixel that you were drawing, you were using sine and you were using radians. So I thought I would work that out before. So I've just, I've set up an array of the values, so I've just gone from 0 to 359 degrees, and I work out the sine value and then I append it to the array, which means when I come down here, instead of having here which would be x times sine, I can't exactly remember what it was, x times sine of a times t plus delta, then I've actually worked out which how big the angle is and made it less than 360 degrees, and then I've looked it up in my list to get the sine value. So I would imagine, rather than having to work out the sine and convert degrees to radians for every single pixel, that ought to be quicker. But I haven't done any timings, it's just that I thought it might be. So we will run this jolly old program. Right, that is a normal Pringle rotating. So I'll go Control C. Then I can increase the speed. If I increase it to 10 and run it, it's moving faster. I'll change it back to 4 so you can see what's going on better. Right, the next thing that we can try, I'll change B to 3. So now we ought to have 3 points going round. Yep, that looks like 3 points going round. Get out of there. Now if we go, make that 3 and that 2, that ought to be rotating vertically, still with 2 crowns. Yeah, I think that's 2 crowns. No, that, if I put that as 1, what will that do? Well, it all looks very, very pretty. Anyway, you can just play around with all of the values. I'll put it back to 1 and 2 and run it again. Now, I'm sure everyone else has done more or less the same thing. The only merit that my program has is that I'm working out the sine values beforehand, and therefore it cuts down on processing time. So that's my program.